Students, all of you, good evening. Welcome to the session. Continuation of circuit theory, that is network theory concepts. I'm discussing the chapter 1, that is fundamentals of electrical circuits. I'm starting lecture 9. With respect to fundamentals of electrical circuits, in important terminology in network theory, all this in the previous session that I already discussed. And I started already Kirchhoff's laws. In that Kirchhoff's laws, in detail about Kirchhoff's first law, that is Kirchhoff's current law that I already discussed in the previous session. Please go through that. And these observations also I given with respect to KCL. You have to concentrate. Before starting the KVL, how to see some important examples with respect to KCL students. See, for example, if any network, if any circuit is given like this, or network is given like this. This is the given network. You try to solve this one. So this is the given network. So this is one branch. This is also one branch. And this is also one branch. This is also one branch. And this is one branch. And this is one branch. That this is given is 2 amperes. It is given. This is 2 amperes. And this is 3 amperes. Let this current is 1 ampere. And this is 7 amperes. This current is I1. And this current is I2. This current is I2. And this is 3 amperes. Oh, sorry. This is not given. And this is 1 ampere. And this is 4 amperes. Then you have to calculate I1 and I2 students. Calculate I1 and I2. Right? It's very simple. This question completely based on KCL, that is Kirchhoff's current law. Yes. What is the solution for this? Can you apply KCL at this node? Apply KCL at this node. You have to apply KCL at this node. What are the entering currents? I1 and I1 is entering. 7 amperes is also entering. Which is the leaving current? Plus 1 ampere is leaving current. I told already entering currents you have to take negative, minus I1, minus 7. Leaving currents you have to take the positive. It's equal to 0. Then from this, what is I1 equal to? Is I1 equal to minus 6 amperes. I1 equal to minus 6 amperes. Clear? Apply KCL at this node. Some of the entering currents equal to some of the leaving currents. Then you can get I1 equal to minus 6 amperes. Then apply KCL at this node. Now apply KCL at this node. If you apply KCL at this node, this is leaving, this is leaving. This 4 ampere is entering, 1 ampere is leaving. Here also apply KCL. 4 ampere is entering, 1 ampere leaving means 3 amperes is also leaving. Some of the entering currents equal to some of the leaving currents. Now, 4 ampere is entering, 1 ampere is leaving means 3 ampere is leaving. At this node, if you apply KCL, 3 ampere is entering, I1, I2 is leaving. Minus 3 plus I1 plus I2 equal to 0. I1 plus I2 equal to 3. From this, what is I2 you have to calculate? Is I2 equal to, yes, 3 minus I1. What is I1? I1 equal to minus 6 amperes. 3 plus 6, 9 amperes. That you got I1 equal to minus 6 amperes, I2 equal to 9 amperes. I1 equal to minus 6 amperes, I2 equal to 9 amperes. Clear, friends? Like this you have to solve. It's completely based on KCL. Any doubt? Okay. See the one more question. For example, if the circuit is given like this is one circuit. Yes, the circuit is given. Okay, this is a given circuit. And different currents are given like this. This is the 3 amperes. And this is the 2 amperes. And this is the 1 ampere. And this is the 5 amperes. Yes. And this is the 6 amperes. and this is I. Find the current. Find the current I. Find current I as shown in figure. Can anybody? What are the current I in this circuit? Come on. Fraction of minute you have to answer. Yes, friends. What is the answer? Apply KCL at this node. Entering current minus I. Entering current minus 5. Leaving current plus 6 equals. Then what is the I you can get? Minus 5 minus I plus 6 equal to 0. That is minus I plus 1 equal to 0. Then I equal to 1 ampere. That is the answer. Just apply KCL at this. Can you try this? One more example. Yeah, this is one op amp IC. 741 op amp. 741 op amp. This 3 milliamperes. This is 4 milliampere. This is 5 milliampere. This is 2 milliampere. This is 1 milliampere. And this is 15 milliampere. And this is IX. Can you calculate what is IX here? Okay, these are the given current streams. 3 milliampere, 4 milliampere, 5 milliampere, 2 milliampere, 1 milliampere, and this is 15 milliamperes. You have to calculate what is IX. Then how to solve for IX? Sum of the entering currents equal to leaving currents. Sum of the entering currents equal to leaving currents. Which are the entering? 3, 4, 15. That is minus 3, minus 4, minus 15, plus 5, plus 2, plus 1 is leaving, plus IX equal to 0. This 722, this is 78, minus 14, plus IX equal to 0. What is IX equal to? 14 milliamps. So IX equal to 14 milliamps. Like this you have to answer. Clear? Yes. Can you try this? One more example I am giving. All these are questions based on KCL based, fundamental questions. This is one resistance, 10 ohms. And this is one current source. Current source. And this is one capacitor. And this is one inductor. And this is one voltage source. Minus plus 8 volts. This current is 12 amperes. Yes, and this current is 4 amperes. This current is 6 amperes. And this current is 5 amperes. This current is, here it is given, IX. This is IX. That's 5 amperes. This is 2 amperes. This is 2 amperes. This is 8 volts. This is 5 millihenry. This is 10 ohms. And this is 30 microfarad. How to calculate what is IX? Can anybody? Fraction of minute you have to answer. Yes, friends. Come on, do it. Here, how much current is entering? 2 amperes. Okay. This is 12, this is 2. Total 14 amperes. In this 14 amperes, sorry. In this 14 amperes, friends, 4 amperes is leaving here. Then remaining 10 amperes is like this. This is 10 amperes. Come on, friends. This is 5 amperes. And this 10 ampere. And this is IX. And this is 6 amperes. This is 2 amperes. No? This is 6. This is 2 means this is how much? 8 amperes. This is 6. This is 2. This is 8 amperes. If it is 8 amperes, entering is 5. Entering is 5. Leaving is 8 means this is how much? 3 amperes. This is 3 amperes. Start here. This is 6 now. This is 2 means this is 8. This is 8. Entering 5. Leaving 8 means this is 3. This is 3. Apply KCL at this. Which are the entering currents? Minus Ix, minus 10, which is the leaving current, plus 3 equal to 0. Minus Ix, minus 7 equal to 0. Then what is Ix equal to? Ix equal to minus 7 amperes. That is answer. Clear? Once you know the concept of how to apply KCL, solving of this model is very easy. Like this you have to proceed. One more model. Can you try this? This 5-star model. Already these models are there in computer exams. This is inductor. And this is the resistor. Inductance L, resistance R. And this is IL. And this is the current. Yes. And this is IL and this is the IR. And this current is 12 cos omega t minus pi. 12 cos omega t minus pi. If IR of t equal to 4 into e power minus 3t. Yes, it's 4 into e power minus 3t plus 3 into e power minus 4t. IL of 0 equal to 1 ampere. Then pi equal to dash. That's the angle pi equal to dash. Option A 60 degrees. Option B 30 degrees. Option C 45 degrees. Option D 0 degrees. Yes, friends, come on, do it. IL of 0 equal to 1 ampere. Then you have to calculate what is the pi. You have to apply concept of KCL, entering currents and leaving currents. Which is the entering current, friends? IL is entering minus IL minus 12 cos omega t minus pi. Friends, plus leaving is IR equal to 0. First I am calculating IR of 0 because IL of 0 is given. That's why I'm doing the IR of 0. 4 into e power minus 0 plus 3 into e power minus 0. This is equal to how much? 7 amperes. Now from this, IR equal to IL plus 12 cos omega t minus pi. I substituted t equal to 0 here. Okay, this IR of 0. Then IR of 0 equal to IL of 0, 12 cos 0 into t minus pi. What is IR of 0? 7. What is IL of 0? 1. 12 cos pi. This 6 equal to 12 cos pi. Yes, from this, what is cos pi equal to? 6 by 12. This is equal to 1 by 2. Cos pi equal to 1 by 2. Then what is the pi? Pi equal to 60 degrees. Pi equal to 60 degrees. Like this you have to solve. Come on. Any doubt? Like this you have to solve different models of questions. I'm giving one more question here. Example. This is the last model. A segment of a circuit. This is a gate question. Gate instrumentation question. Sorry, gate electrical question. A segment of a circuit. A segment of a circuit as shown in figure. As shown in figure. VR equal to 5 volts. VC equal to 4 sin 2t. 4 sin 2t. The voltage VL is given by. The voltage VL is given by. VL is given by dash. Yeah, this is the elements it is given. This is the current source. This is a given figure. It's 2 amperes. And this is the resistance. So it's a 5 ohms. plus minus is a capacitance. So 1 farad, 1 farad, and this is the inductance. It's a 2 Henry. It's a 2 Henry. This 5 ohms, the current direction is given like this. This is plus minus, and this also plus minus. Yes, friends. Then you have to calculate the voltage across inductor. Then apply KCL. Before applying KCL, always the current is positive plate to negative plate. This is IC, and this is IL, and this direction is IR. Then apply KCL at this node, friends. If you apply KCL, entering currents, IR is entering. Next, what about the 2 amperes? The 2 ampere direction is like this. Sorry, this is the given direction. Correct it. This is the 2 ampere direction. 2 amperes is also entering. IC is leaving, IL is also leaving. IC plus IL equal to 0. Then what is IR equal to? VR by R. IR equal to VR by R. What is VR? Voltage across the resistor. This is a 5 volts now because I have to calculate IR. 5 by 5. This is 1 ampere. How to calculate IC, students? IC equals C into dVC by dt. C is 1 farad. D by dt of 4 sin 2t. This 4 sin 2t, how to get 8 cos 2t. By differentiation, 8 cos 2t value. I calculated IC. C is 1 farad. This is VC. Now, how to substitute all the values? This minus IR. IR is how much, friends? 1 ampere. Minus 2. IL you have to calculate. What is IC? 8 cos 2t equal to 0. From this, what is IL equal to? 3 minus 8 cos 2t. How to calculate VL? How to calculate VL? VL equal to L into DIL by dt. L is how much, friends? 2 Henry. D by dt of what is IL? 3 minus 8 cos 2t. This is equal to differentiate with respect to dt. 0 minus 16 cos 2t. Cos of differentiation minus sign. Cos of differentiation is minus sign. Again 2 is there now. 2t is also there. You differentiate this 2. 2 into 8, 16. Cos of differentiation minus sign. Minus into minus plus sin 2t. Then what is the voltage across the inductor, students? 32 sin 2t. 32. This is the gate mode. The voltage across the inductor equal to 32 sin 2t. Okay, all these basics questions that is based on the KCL. So many other models also there. Later on I will share some questions which are asked in GATE exam and also in ES exam based on this model. Later on you try that. The next one is Kirchhoff's second law. That is the Kirchhoff's voltage law. That is KVL. Kirchhoff's voltage law is nothing but a KVL. Then before explaining the KVL concept, first you have to know the sign convention. By knowing the sign convention only, you have to apply the KVL. See, for example, let this is the battery. So this is the battery. Let this is the point A. Voltage at point A is VA. This is point B. Voltage at point B is VB. If you are moving positive to negative, if you are moving positive to negative, take the voltage as a negative because voltage reduction. If you are moving negative to positive, take voltage as a positive because voltage is rising. Now, for example, if you are moving like this, if you are moving, this is a sign convention we follow. Very important throughout network theory analysis, we follow this. If you are moving negative to positive, take voltage as a positive, take voltage as a positive because of voltage rising. Because of voltage rising. This sign convention I am following. We are moving negative to positive. We are moving negative to positive. Then you have to write the voltage at point A is VA. Let this is E. Negative to positive we are moving. Take positive. VA plus E is equal to VB. VA plus E equal to. If you are moving positive to negative, if you are moving positive to negative, positive to negative, positive to negative, take voltage as negative. Take voltage as negative. as a negative. Students, because voltage rising. Because voltage rising. Voltage rising. That is, if it is given like this is the source, this is A, this is B. Voltage at point A is VA, voltage at point B is VB. If you are moving positive to negative, like this. Here, negative to positive, this is positive to negative. Then voltage at point A is VA. Positive to negative means take negative. That is minus E equal to V. Like this we have to consider. For example, if any resistor is given like this, let this current I, wherever the current is entering, that is a positive, this is the negative. Let this is A, this is B. Then how we can write students? VA, positive to negative, no? Positive to negative means negative, minus IR equal to VB. Clear? When the current is enter, that plate you have to take, that point you have to take the positive, then it is negative. We are moving positive to negative means negative. That is I into R, IR equal to VB. See, for example, if it is given like this sign convention is important. This one resistor, this one battery it is given. This is A, this is B. Let this is the current direction. We are moving like this. In the direction of current only we are moving in the direction of current only. If the current is enter here, plus this is minus, this is R. We are moving like this. It's VA minus IR. Let this is E, positive to negative. Minus E is equal to VB. We are moving positive to negative, take negative, negative to positive, take positive. See, for example, if it is given like this is R, this is battery, this is B, and this is A. This is the current direction. This is R plus minus. This is VA minus IR, negative to positive, no, positive plus E equal to VB. VA minus E, VA minus IR plus E equal to VB. One more example. For example, if it is given like this is negative to positive. This is A and this is B. Actually, current direction is given like this, but you are moving like this. According to current direction only, this is plus minus R. Now you are moving like this. Current direction is like, according to current direction, this is plus minus. Not according to your movement. According to current direction only, you plus minus. Now you are moving from like this. This is VB. This is E now. Positive to negative, negative, minus E. Negative to positive. Negative to positive, plus IR. This is equal to VA. Clear? According to current direction, you have to take the plus minus. Now, once you are moving like this, negative to always negative to positive means positive. Positive to negative means negative. This is equal to VA. Clear? This minimum knowledge that you have to consider. This is sign convention. Then by knowing this, then we start KVL. That is Kirchhoff's second law. That is Kirchhoff's voltage law. That is the KVL. Kirchhoff's voltage law is nothing but a KVL. It is defined in loop or mesh in a closed loop. That is KVL is defined in a closed loop. It is defined in loop or mesh. What is the loop? What is the mesh that you? It states that algebraic sum of the voltages or voltage drops in any closed path of a network that is transferred in a single direction is 0. That is, in a closed loop, sum of the voltages is equal to 0. In other words, in a closed circuit, the algebraic sum of all the EMFs and algebraic sum of all the voltage drops is equal. Algebraic sum of all the EMFs and algebraic sum of all the voltage drops. Algebraic sum of the EMFs equal to algebraic sum of the voltage drops. See, for example, this is one closed circuit. This is one closed loop circuit. This one closed circuit. This is R, and this is L, and this is the system. This is a capacitor. R, L, C. This is V. Let the voltage across the resistor is VR. Let this is the current direction. Enter at positive terminal. This is plus minus VR, plus minus VL, plus minus VC. Then apply KVL here. Follow the sign convention. If you apply KVL, positive to negative, negative, minus VR. Positive to negative, negative, minus VL. Positive to negative, minus VC. Negative to positive, plus V equal to 0. That is algebraic sum of the voltages equal to 0. That is V equal to VR plus VL plus VC. That is the total EMF equal to sum of the drops. This is the total EMF. This is the total voltage. This is the voltage. These are the drops. The total EMF equal to sum of the drops. algebraic sum of the voltages is equal to 0, or sum of the EMFs equal to sum of the voltage drops. This is only one EMF that is equal to sum of the drops. Now, how to write a voltage? We know that voltage is nothing but work done per unit charge. That's starting in the fundamentals I given. W by Q equal to, this is energy or work done. Energy or work done. Energy or work done is equal to WR by Q, WL by Q, WC by Q. Work done per unit charge. This Q cancel. Then what the W equals, friends? W equal to WR plus WL plus WC. W equal to WR plus WL plus WC. That is, KVL is a conservation of energy in every loop of a lumped electric circuit. But KCL is a conservation of charge. But KVL is a conservation of energy. KVL is a conservation of energy. And one more point to remember, KVL is independent of type of element. Whatever the element it is present, you have to apply KVL. Resistor, inductor, capacitor. Any element is present, you have to apply KVL. And it is a law of conservation of energy. KVL expresses conservation of energy in every loop of lumped electric circuit. It expresses conservation of energy in every loop of. KVL is independent of nature of element present in a loop. KVL is independent of nature of element in a loop. That is, it may be linear or non-linear, active, passive, time invariant, time varying. Any element you have to apply. KVL is also only for lumped elements. It is not distributed elements. KCL is also only for lumped element. KVL also only for lumped element. Only for lumped elements. KVL is also applicable for only for lumped elements. For any circuit or network, number of KVL equations required equal to number of meshes. That is B minus N plus 1. How many number of KCL equations are required? NP minus 1. NP is number of principal nodes. NP minus 1. Similarly, how many number of KVL equations are required? The number of KVL equations are required equal to number of meshes. That is B minus N plus 1. This is important. How many number of KVL equations are required? Okay, that you have to concentrate. Clear, friends? KVL also only for lumped elements. For any circuit or network, number of KVL equations required equal to number of meshes. Just for understanding, can you apply KVL in this loop? Try to apply the KVL in this loop. If you apply KVL, yes, friends, take this is I, positive to negative, minus IR1, positive to negative, minus IR2, minus IR2, yes, friends. Negative to positive, plus V2, negative to positive, plus V1, equal to 0. Then from this, yes, friends, V1 plus V2 equal to IR1 plus IR, IR1 plus IR. Then take I is common, R1 plus R. This is V1 plus V2. Okay, like this, you have to apply the KVL. If you apply KVL in this loop, any direction you have to take, either this direction. Say, for example, for same circuit, I am applying like this. You can get same answer. Any direction. You follow only one direction. Take this path or this path. Only one direction. But I am taking like this. Negative to positive. Positive. I into R1. Positive to negative. Minus V1. Positive to negative. Minus V2. Negative to positive. Minus IR. Negative to positive. Plus IR. And from this, V1 plus V2 equal to I into R1 plus R. Are you getting same answer or not? Any direction you take. But one direction. In one element, one direction. Another element, different direction. Don't take like this. You follow the one direction. You can get the same answer. Can you try this? Apply KVL here. You take any direction. I'm giving like this. Then apply KVL here. Then apply KVL here. Same circuit I given. Prove that these two are equal. The final relation is equal. Any direction you have to take, we can get same answers. Then here I have to give some final conclusion points with respect to KVL and KCL. After that, you have to see some practice questions with respect to KVL also. Just a minute. Sign convention is very important. This is the conclusion points with respect to KVL and KCL and Ohm's law. Field theory can be applied for low and high frequency applications. In field theory, accurate results are obtained by developing mathematical equations and it is complex. We can get the accurate results in field theory approach as compared to KCL. Network theory is applied only for low frequency applications. Network theory approach is low frequency application. But field theory is both low and high frequency. KVL and KCL fail for high frequency application. That is, we can't apply for field theory at high frequency. Field theory at high frequency. KVL and KCL fail for distributed parameters. It is applied only for lumped parameters. Since in the distributed parameters it's not possible to separate inductance, capacitance, resistance, effect. That's why KCL and KVL is valued only for the lumped parameters. It is failed for the distributed parameters. KVL and KCL are applied only for lumped parameters. Linear, non-linear, unidirectional, bilateral, time invariant, time. Any case, no problem. But it is only lumped parameters. It's a linear, non-linear, unit, bidirectional, time invariant, time variant. Any case it is applicable. But condition is it must be lumped. But Ohm's law can be applied only for lumped and linear. Lumped and distributed, we can apply. Ohm's law is applicable for both lumped and distributed, but it is a linear case. It is not applicable for non-linear case. KVL KCL is applied for any case, but condition is lumped. Ohm's law is applicable only for linear, but it may be lumped or distributed, it is applied. In lumped case also it is applied. But KVL and KCL is only for lumped case, but it is not for distributed case. Yeah, these are the conclusion points that you have to concentrate. Here I am solving one question with respect to KVL, that you try to solve this question. For example, if for the circuit shown in figure, for the circuit shown in figure, Vx equal to dash. In this circuit, what is the value of Vx? This is 2 ohm resistance. This is 8 volts. This is 3 ohm resistor. So this is plus minus Vx. This is 3 volts. This is 3 volts. And this is 6 amperes. 6 amperes. And this is 1 ohm. And this is 3 volts. And this is the 3 volts. Can you find, this is 2 volts. Can you find what is the Vx? Come on, do it. Here I have to give 2 methods. What are the method you have to convert? That method you have to follow. So I'm giving method 1. This is 6 amperes means this also 6 amperes. Why? This is open circuit. Once you know that current, enter at this terminal, positive, negative. 6 into 2, 12. Then apply KVL in this loop. Apply KVL. Applying KVL 1. Then this is minus positive to negative, minus 12. Positive to negative, minus 8. Negative to positive, plus 3. Negative to positive, plus Vx equal to 0. There is no current to 3 ohm resistor because the open circuit. Current is flowing here. Okay. Then from this, minus 20 plus 3, minus 17. Minus 17 plus Vx equal to 0. And what is Vx equal to 17? Vx equal to 17. Clear? That is method 1. If you have to solve method 2 also. Method 2. To find method 2, yes, friends. You have to find what is the voltage across 6 ampere. For that, you have to use this loop. Once you use this loop, this one, positive to negative, minus 12. Positive to negative, minus 8, like this. Positive to negative, this is plus, this is minus. Current is flowing like this. Minus 6, negative to positive, plus x equal to 0. Then we can get x equal to 26. If x is 26, then apply KVL in this loop. KVL 2. KVL 2. If you apply KVL, positive to negative, minus Vx. Positive to negative, minus 3. Positive to negative, minus 6. Negative to positive, plus 26 equal to 0. Here also you can get Vx equal to 17 volts. You can get same answer. Directly you apply KVL here. Or if you want to apply KVL here, first you find this one, voltage across this. To find voltage across this, take the dotted line KVL. Dotted line KVL. Then you can get x equal 26. Then solve for the Vx. Vx equal to 17 volts. Yes, friends. Like that you have to proceed. Vx equal to 17 volts we are getting. Can you try this? One more example. This 2 ohms plus minus. This is 3 ohms. This is 2 ohms. This is 3 ohms. This plus minus V1. This is minus plus V2. Find V1. Find V2. Can you try this? Simple question. And this is given 20 volts. It's 20 volts. Like this is, I am taken this is I. If you apply KVL, minus 2I according to current direction, plus minus. Minus 3I plus 20 equal to 0. From this, you have to calculate what is I. 5I equal to 20 students. I equal to 4 amperes. If I equal to 4 amperes, what is V? According to current direction, this plus, this is minus. This plus minus, same now. Then 4 into 2, 8 volts. What is V2? According to current direction, this is plus minus. But given is negative. Then V2 equal to minus 3 into 4, minus 12 volts. Clear, students? Why it is a minus 12 I taken? Why I taken negative? This I taken negative because according to current direction, this is plus this. But given polarity of this voltage is V2 taken. I have to calculate according to this polarity only. That's why it is a minus 12 volts. Opposite polarity we are getting now. That's why it is a minus 12 volts. Like this we have to solve. Clear? Any doubt? Same model I'm giving. Can you try this? For example, this is plus minus 32 volts. Sir, minimum fundamentals, sir. Once you know the fundamentals, solving of different models of questions are very easy in network. Sign convention is important. 4 ohms. This is V1. 8 volts plus minus 8 volts. And this is V2. This is V2 plus minus V2. And this is 2 ohms it is. Find V1 and V2. Take the current. Any direction you take, no problem. This I take an I. Then apply KVL. Minus 4I. Minus 8, positive to negative. Plus 2I. Plus 32. Equal to 0. Minus 4I. What the? According to current direction, this is current direction is. According to current direction, this is plus minus. According to current direction, this is plus minus. This is minus 2. Positive to negative, na, minus 2. I am taking according to current direction. Minus 2. This is 6I plus 24. That is 6I equal 24. What is I equal to 4 amperes. Now tell the students what is V1. V1. This polarity and this polarity is same. 4 into 4, 16 volts. 4 into 4, 16 volts. What is V2? According to current direction, this is plus minus, but they given plus. This is plus, this is minus. But they given this is plus, this is minus. Opposite polarity. 2 into 4. This is equal to minus 8 volts. That is V1 equal to 16 volts. V2 equal to how much, friends? Minus 8 volts. Like this you have to. Okay, this is the concept of how to apply KVL and KCL. How to apply KVL and KCL. I think you got some minimum knowledge. What the KVL, what the KCL, how to solve the problems, how to minimum fundamental problems. The extension of this, how to see some important models. After completing what are the types of sources, if the elements are connected in series, if the elements are connected in parallel, what are the equivalents. After knowing that, you'll see the different models of questions. Okay, I'm ending the session. This is about the today's session. Thank you. Any doubt? All these models next session I will solve. Any doubts, friends? Once again, please go through this. Sign convention is very important to solve the problems. And how to apply KCL and KVL also you have to consider. Okay, thank you very much. I'm ending the session.